Okay, here's the second video in this series. We're solving a system of linear equations by method of substitution. And, well, today we're going to solve an equation where you actually find that there are no solutions. All right, so there's a system where you can get one solution, there's a system where you get no solutions, and there's a system where you get infinite solutions. And it has to do with the lines. And what we're going to find today are that these lines, line 1 and line 2, are parallel. Okay, so line 1 is parallel to line 2. All right, and that's going to give us no solutions. So no matter how far you run out, you will never, this distance will always remain the same between the two lines. So if this is distance D, this distance D, way down into the future, will still be D. It will never decrease because the slopes are the same. So what are you saying? M1 equals M2. If you have your equation, y equals mx plus b. These m's of line 1 and 2 are the same. The b's are not the same. The b's are different. Okay, so these are different. The intercepts. Okay, but these are the same. Okay, when we had one solution, recall, when we have one solution, m1 is not equal to m2. In b1, it doesn't matter if b1 equals b2 or b1 does not equal to b2. Either way is okay. Okay, but this would be the case for one solution. The slopes are different, and when the slopes are different, you're going to get these lines, because they're lines, have to cross somewhere in space, in two-dimensional space, that is. We call that R2, two-dimensional space. If it's three-dimensional space, they may never cross, but in the plane here, in a plane, they will cross. Okay, let's take a look at our example today. We have 8x minus 4y equals 6. And I have 2x minus y equals 9. Now, as you see, it's I'm going to call this equation 1, equation 2. Here's our system of equations. This is the system right here. That's your system of linear equations. Why are they linear? Because this is to 1 first power, that's to the first power, that's to the first power. That makes them linear when you got the x and y's to the first power. Okay, or you could have the x to a 0 power, so x can be actually the 0 power or 1. So you can just have a line like, for instance, y equals 3, then in which case then x is equal to 0, right? Because then it's really y equals 3 times 1, because anything to the 0 power is 1, see? So you could have it 1 or 0, but the y is going to be to the first power. Okay, in this case. These are lines. We have a system. We're going to solve them by using the method of substitution. I can't tell if these slopes are the same or different from this point of view, at this point. So I have to run the numbers. So I'm going to say, I'm going to resolve equation 2 to get y. Okay, because y is by itself, I'm going to choose the easy fruit and solve for y, because I have to do another step to get the y in, or the x in these equations. I chose this one here. I'm going to attack first. Okay, so equation 2 to get y. All right, so let's rewrite equation 2. And now I have negative 2x to both sides. Let's get y alone. Negative y equals 9 minus 2x. And then I'm going to divide by a minus 1. Everything by a minus 1. So I get y equals 2x minus 9. So there's equation 2 again, but just resolved for y. Okay, now I'm going to put equation 2 into equation 1. That means sub it in, right? I'm going to sub it in. Okay, so let's rewrite equation 1. 8x minus 4y equals 6. Okay, there's equation 1. I'm going to take this y from equation 2 and put him in there, whatever that value is, and it's all this. If you just put equation 2 into equation 2, you would end up with a true statement, but it would be meaningless and you wouldn't get anywhere. I don't have the time to go into that at the moment, but let's just resolve this. You have to sub one into the other for this to occur. Okay? You can pick any one you want, but you have to sub it into the other equation. And I'll show you some other time, I guess a 3 equation system. This is only a 2 equation system. Okay. Now we're going to continue on. We're going to take 8x minus 4, the quantity, 2x minus 9, okay, equals 6. So I made the substitution. This is now a new equation. I'm calling this equation 3 because it's a combination of the 2 equations. Okay, we have to use our distributive principle again. So I get 8x minus 8x, okay, and plus 36, okay, equals 6. All right, we have to collect like terms. So we have these two, but I have to move this guy over here. So I'm going to put a minus 36, a minus 36. Add both equations. Now what happens here? I get 0, right? From adding a positive 8x and a negative 8x, I get 0, right? And then on this side, I get what? 30, negative 30. So it says to me, 0 equals negative 30. This is a false statement. Okay, a false statement. When you get a false statement, something that is not true, it's not true. Okay. Something that is not true, that means there's no solution. Okay? That's what that means. Since you have no solution, this is called an inconsistent equation. Inconsistent because there's no solutions. Okay? And so that's the end of that. I mean, so what happened here? I can tell you that these two guys went off like this, and one is parallel to the other. That's what's happening here. That's why they never cross. They don't share a common place in space, so there is no solution to this system. Okay, that's it for this video. Thank you.